Everyone, this is Derek, and this is going to be just a couple examples of the definite integral as area with applications. So this first one goes, a large company has installed a new robotic equipment. In its assembly areas, the new equipment produces a savings that accumulates at a rate of, so this one's going to be a rate, and this is in thousands of dollars per month, and that is totally important. Determine the savings in thousands of dollars over the first year period, round to the nearest $1,000. And then they have a little graph on the problem, and it looks like this. It's not overly helpful. It's just kind of showing that you're going to integrate from here to here. And actually on the little graph, they have a little 1 year here. And again, thousands of dollars, so that will matter. So T in this case is in months. This is thousands of dollars per month. And then our S is going to come out in thousands. And so that means if we had 2 as an answer, it'd be 2,000. So what we want to do is integrate this from 0 to 12 months, as opposed to 0 to 1 year. And 33e t dt. So let's bring the 33 out front. And we're going from 0 to 12, e 0.16 t dt. And then when we have, when the argument in our, or the exponent is a little bit more complicated, we like to make that our u. So we'll do u equals 0.16 t. That makes our du 0.16 dt. So this, I'm just going to divide that over. And then du over 0.16, or you can think of it as a 1 over that, equals dt. So that should allow me to do my substitution. And then this piece right here, I'm just going to drop right out front with the rest of the constant. And now we can integrate, and we'll just get 33 0.16. And then this will be e, and then u was that 0.16 t evaluated. Oops, that dropped off. 0 to 12. So basically we're going to toss 12 in there. I'm going to do the same thing where I write this little fraction out front. And so I would just do this math in the calculator and then times it by this. So this will go e to the 0.16 times 12, and then e and minus. This would be a 0 right here, so e to the 0, which is 1. And then tossed all out in the calculator, I got 1200.57, blah, blah, blah. And we're going to the nearest thousands. So careful, that's not thousands, because this answer isn't thousands. So the thousands place is the ones place. So this is actually million. So this would be 1201 because of that 0.5 we're rounding up, and that's thousands. So 1,201 thousandths. Okay, so for this one, person's investment is expected to produce a continuous stream of revenue of this dollars over the next 12 years. So we're getting out dollars, we're putting in years. And this is from time A to time B, so that's gonna be from 0 to 12 for the integral of that. And then we're asked to find the revenue generated over that 12-year period. So we are finding the area under the revenue stream, which will give us the actual revenue. So for this, let's see, I'm gonna write that 3,000 out front, I think right away. I'm gonna go from 0 to 12, and then that I'm gonna think of as t plus 10, and I'm gonna write that as to the 1/2 dt. And again, anytime it feels like a chain rule, that's probably a good place for u substitution. So we're gonna do u equals t plus 10, and that makes our du equal, that would just be dt, which is perfect. So now we have 3,000, 0 to 12, u to the 1/2 du. Integrating this, we would get 3,000, and then that would be times u. Here we're going to add 1, so that'll be u to the 3/2 over 3/2 and evaluated 0 to 12 still, and I'll put this t back in here in a second. So I'm going to take this fraction, and remember when we do this, we bring it up and flip it. So that will make this be 3,000 and then times 2/3, and then u to the 3/2. 3 goes into 3,000, that leaves 1,000 times 2. And so now we're at 2,000 u to the 3/2. And now that I finally kind of have all my algebra cleaned up, let me write this halfway decent. So we'll go 2,000, and now our u is really t plus 10 to the 3/2 evaluated on the intervals 0 to 12. And so from there, I just did 2,000 times, let's see, this would be 12 plus 10, so that'd be 22 to the 3/2, minus 0 plus 10 would be 10 to the 3/2. And I just chunked that in my calculator, and this one was round to the nearest cent, and so I got 132.74 when I did it.